Well, greetings everybody. Here is another problem from our assignment that involves the chain rule, and it's very abstract. And what I mean by saying that it's abstract is like, here's an example I used in another video where I find the derivative of sine of pi x squared with the chain rule. Everything here is known. The derivative of sine is cosine. There's a formula to know that. And the derivative of pi times x squared is pi times 2x. Right, so everything is known here. I know what functions I'm dealing with. Every number is revealed. Okay, there's nothing unknown about this. But in this problem, I have these functions that aren't known from the beginning. Like I have this function h of x, f of x, g of x, all right, p of x, and none of it's known. I have some data, okay? I know that, for example, if you plug 1 into f of x, you get 4 as a result. Okay, I know that if you plug 3 into g prime of x, you get 5/8 as a result. I have some data, I have some particular numbers, but I don't know what these functions are. So it's abstract, okay? I'll have to really understand whatever rule is at play here in order to answer the question. So here's how I would do it. First thing I notice, these are composition functions. It's one function inside of another. The g is inside the f in terms of order of operations. If I was to evaluate this function, I would have to use the order of operations of calculate what g of x is first, and then find f of that number. That's what a composition of functions is. The same thing with this other one. So that's what I have. These are h and p are composition functions. If it comes up that I look for the derivative or need the derivative, the chain rule is what I use, okay? And in fact, I do want h prime 4, the derivative of this at 4, and p prime of 3, the derivative of this at 3. Okay, so those are compositions. I want these derivatives. The chain rule is applicable. So here's the way I would write the chain rule in general terms to apply to any composition. You know, not just f of g, but you could write g of f, or there's h and f and g and p and g. There's all these functions. You have to accept that the notation and the particular letters we use might be different. But this is how the chain rule would be used for this unknown composition. Okay. Now I would say real quick as a disclaimer, through this video and other videos that I've made, I might write the chain rule in other ways. There are many ways you could write it. One factor is I could use different variables. These functions don't have to be called f and g, and when I wrote this down, I didn't have to use f and g. So maybe the letters are different, okay? But it's the idea that matters. The pattern, all right? The formula. Don't get too hung up on whether this is f or g prime, or it could be different as long as the pattern is the same. And here's a screenshot from the textbook that's linked with our class. We can also write it like this with Leibniz notation. All right. So yes, good or bad, there are many ways to write the chain rule because there's variability with the notation that we use in calculus anyway. All right. Now I'll put that aside. It's always something you could ask about if you get hung up on the notation. And I do think that learning how to understand the notation is a big part of doing math. Okay, now here goes. Say we do h prime 4 first. According to this, h prime x is f prime g of x, okay, then times g prime x. You see it? And then if you want h prime 4, that would be letting x be 4, f prime g of 4 times g prime 4. Now, if I didn't have this table of values, if I didn't have this data, I'd have no way to answer that. I mean, the functions are already unknown. Okay, so what do? G of 4, well, I can find that. G of 4 is 4, okay? And so I have f prime of 4. And then g prime 4 is 3/8. So I get f prime 4 times 3/8. Now what's f prime 4? F prime 4 is -2 right there. And so, okay, that's turns out our answer is -2 times 3/8. Reducing that, -2 times 3/8, cancel the 2 with the 8, we'll get -3/4. -3/4 That's our answer for h prime 4. I would find p prime x the same way. It's a composition. The chain rule unfolds with g prime f of x times f prime x from this and this. Okay? And then if you want p prime 3, putting 3 in for those x's, finding our values from the data on this table in the same way that I explained in this first question gets me negative 21 over 8. All right? Okay, so that's the chain rule applied in what I feel is a very abstract situation. Abstract in the sense that I don't know what these functions are, but I want you to see that I can apply the rule the same way no matter what.